Welcome. In this tutorial, we are going to learn about module, package, and import. So what is module? A module is a Python file, a file with .py extension which contains Python definitions and statements. And package is a collection of modules. So in Python, a package is a directory which contains modules, a .py files, and init file. Now what is init file? Init file is what makes your normal directory in your file system into a Python package, and whatever the content inside .init file, it gets automatically executed when importing a package. Or you can also control what are the modules which are automatically loaded when using wildcard import using init file. So in Python there are two kinds of packages. First one is regular packages and second is a namespace package. So for Python version 3.2 and earlier, the regular package is the only package available with the Python. And for Python version 3.3 and later version, regular package is available across all the versions. So what is the regular package? Regular package is a package which requires you to have init file inside the directory which you want to treat it as a package, and path to that directory or package must be registered with the sys.path. And with namespace packages, your init file is not required to be in the directory which you want to treat it as a package. And namespace package is available from Python version 3.3 and later. And one of the main advantage with namespace package is you can have a package which spans across the multiple directory that you cannot do with the regular packages. And same as regular packages, with namespace packages you required to register a path to the sys.path. So first we will see the content of sys.path. So you need to import sys, and sys.path returns the list of string. It contains the list of paths where the Python looks for the module or package when importing a module or package. So let's first print what are the paths registered with the Python right now. So these are the paths currently registered and the location at which the Python will look for the module and packages. Now if you want to add a new path, you can use sys.path.append, which will append your given path to the sys.path. Or alternatively, if you are using PyCharm, you can go to the file, settings, project, and project structure, which will contain all the folders inside your project. You can select any of the particular folder and click on sources, which will register your path to the folder to the sys.path. And if you click on apply and OK, which will mark that folder as a color blue, which means the path to this folder is already registered with the Python sys.path. And if you want to see that in sys.path, you need to restart your console. And if you restart it and again if you print it, as we can see, the newly added path gets printed. Same way, alternatively, you can add or remove sys.path entry using selecting a folder in your project view by right clicking on the folder, go to the mark directory as. Here you will see unmark or mark as a source root. So this folder is already marked as a source root. Now we can unmark it. So as we can see here, it will change its color, which means the path to this folder is unregistered. Now again, if you want to register it, right click on it, mark directory as, here we can see a source root, which will mark that directory as a path to that sys.path. And alternatively, if you don't have admin rights to register path to the interpreter, you can export Python path variable, environment variable, and append your module path to the Python path content. And here module path is need to be replaced with the path to your module. Next topic is PyCache. PyCache is a folder which is get automatically created in your package or the path to your directory, which is registered with the sys.path, which contains compiled version of each module inside it. So if you have already registered a folder or a directory to your sys.path, and if you open it after running some Python program, you will see a PyCache folder. Okay, so this is the content of a directory which is treated as a package. So inside it, it contains PyCache folder, and if you examine the content of PyCache folder, it contains .pyc, which is a compiled version of modules in the package. So we write a Python file in Unicode and machine understand the binary. So while loading that, you need to convert it into the binary. So PyCache contain compiled version of your Python module, which will improve your loading time. And it automatically recompiles if you change the source code in .py file. So when you register your path to sys.path, and when you run it, run the package or module, in the PyCache directory is automatically generated. So you don't need to manually do anything to it. Next is importing module and package. So in order to import a module, you write import and module name. So for example, if you want to import a traceback module, so we will write import traceback, which will import your traceback module. Now if you want to import functions from module, you can write this syntax: from module traceback import whichever functions you want to import. So this import statement will import two functions only from the module traceback. And if you want to import all the functions inside the module, you can write from traceback import star. So this is a wildcard import, which will import all the functions and variable inside the traceback module. Same way, if you want to import a package, you can use import package name. So we saw date and time package, which contains multiple modules. So we can import a package using import and package name. Now if you want to import a particular module from package, you can write from module, from package, date and time, import module, date time. So this will import date time module from package, date time. And if you want to load all the modules from package, you can use wildcard from datetime import star, which will import all the modules from the datetime package. We know some of the modules of datetime package are datetime, time, date, time delta. All are accessible using this wildcard import. So same is here. We can execute all this function by using wildcard import, and all the modules inside the package are accessible using single import. Same way here we have used wildcard import for module traceback, which will import all the functions of traceback module. So what if two modules have a function with the same name and we want to import both of them? Then we can use alias. So using alias syntax, we can rename any function, package or module while importing it. So after as you provide the new name for the function, module and package. For example, in Python built-in module math and cmath both contains sqrt function, and we want to import both of them, then we can use alias so that they don't get intermix. So here, as we can see, we have provided different name to both of the function, and both functions are accessible using the given new name. Same way you can assign an alias for a module also. So here the traceback module is aliases as a tb, and with tb we can access any of the function inside that module instead of writing the full name traceback. Same way you can also use an alias for package. So package datetime can be accessed using dt, and using dt we can access any of the module inside it. Okay. And same way you can use from package import module and assign that module an alias name using as dt. So here the date and time module is assigned an alias dt. So you can use a function of the date and time module directly using assigned alias. Now next topic is user defined module. Now we want to define our own module. So here in project structure you can see we have already marked the current directory in which we are using or we are having the module, this 01 file .py. We have already marked it as a sys.path. Okay, marked it as a root, content root. Okay, so while importing it will look inside this directory. So it contains two modules directly inside this folder which are already accessible as a modules. So inside that directory, same directory, if there is another module and if we want to import it directly, we just need to write its name. So here we can see we already have another module named module 2 which contains some variables and functions. So if we want to import it, we can just write import module name, which is the same name as a file name, and after importing it we can access all the variables and the function inside the module. So if we execute greetings, it will execute greetings function, which is written inside the module 2, which will print a message based on current time. So from this module we can also import a particular variable or the function, but this is not a good design to import a variable from the module, but still we can access it. So if we know here we have int1 variable, same we can import it, and if we print it, it will print the same value which is defined inside the module 2, as you can see here. Same way we can mix a function and variable inside the import of the module, which will import all of the listed functions and variable from the given module. So we can access the functions of that particular module which we are importing. So if we import multiple function and execute it, it is printing the value of the int1 variable inside the module 2. Now, after importing variable, which you should not do, if we try to modify the variable, this is what happens with mutable and immutable data type. So here we are importing both immutable and mutable data types, and we are trying to modify it. So here we have changed the value of integer and we have added some strings to existing list. And if we print it, if we see int, which is a immutable data type, it is not changing its value, but list, which is a mutable data type, it changes its value. So it will become hard to track the variable values if you are importing a variable individually. You can import function from it, that is fine, because it contains its own local variable, and as we saw in functions, you should not modify a mutable data type inside the function definition. You must always create a copy of it if you are modifying it. So using that design guideline, using import, you can import the functions inside the module. But for the recommended import, you must import module as a whole package, and after importing module, the correct way is you can import module and using the module namespace, either module 2, or you can assign an alias for it, such as here assign m1, and from there you can access those variables and function. This is the safest way. So you can modify it, the variables, or the access the function. So using same way, if we modify it, as you can see, it is changing the value of immutable type as well as the mutable type, and with the namespace your code also become more readable what you are accessing and from which namespace you are accessing the functions and variable. Now we will see defining a user defined package. So it is same as creating a directory inside your file system. So here inside our current working directory, which is this module and package, we have created a folder with init file, which will mark it as a regular package. and inside this package A we have a module 1, which contains a function which prints message hello from the module 1. As this folder or directory, it is already marked inside as a sys.path or a content root, we don't need to explicitly register this package. So if we want to access this package, if we want to access this particular module, we must travel through the hierarchy from the path we have registered to the sys.path. So after this path, it comes the package 1, and package 1, inside it we have module 1. So first we will go to the package A, and from inside we know there is a module 1, so we will import module 1 as M1. So now we have imported this module, and we can access all the functions and variables inside it. And if we try to access this say hello, it will execute the say hello which is inside from this module 1. And as we can see, it is printing the same message which is inside this return. So here we are writing two things. First, from the package we are importing module, but we can also traverse to the module using dot pattern. So we want to travel further, you can put a dot, so it will travel further. So from the content root, we know there is a directory, so we will go to package 1, and if you want to go inside it, you write .1. So from inside we want to traverse through module 1. So we have here reached to the module 1. So same way you have an inner hierarchy, you can also traverse inside it. So for example, here we can see the hierarchy of module package A, package B, and inside this module 3. So if you want to traverse to the module 3, you can write same way like this. So from package A, we will go inside the package A, which contains package B, and inside the package B there is a module 3. So same way we can travel. Instead of from this syntax, we can only traverse 2 steps, but using dot syntax you can traverse as deep as you can go, or the hierarchy exists inside your file system. So if we execute it, it will print the message which is executed by the function say hello. Now we will see what happens if we have an executable code inside the module. So here in package A, there is a package C inside it, and there is a module 5 file inside the package C, so which contains function say hello and also contains some executable code. So this is the definition, and this is the executable code, which means it is calling the function or printing some message to the standard output, which is a executable code. So when you are importing a module, all the executable code gets automatically executed when it is imported. And one important thing to remember is Python will only import any module only one time, wherever the first import is invoked. So after importing first time, if you try to again import it into the different module or different package, it will only return the referenced version inside the memory. It will not again re-import it. So when importing the first time, all the definitions and executable code inside your module gets automatically executed. Okay, so for example, this Python module contains executable code and it is imported only first time. So here we are importing first time. So if we execute it, here we can see it is automatically executing this executable code, such as invoking say hello, which is printing hello world from module 5, and print message string, which is saying say hello. So it is automatically executed when the module is imported. But if we try to again import the same module, you will see nothing, because it is returning already imported the module. So this module is already cached inside the memory. It will not again import the same module. So what if we want to avoid executing the executable code inside the module? So we need to place the executable code inside the if block, and we need to check whether the name is main. So when executing a module, current module which is being executed is assigned the name as a main, and all the other modules which it is importing is assigned the same name as the file name or the package name. So if while executing it, if the package name or the module name is main, which is from this file only if we are running, then and then this executable code is executed. Otherwise, if you are importing it, this code is not executed. So first we will run from this file, which will make the current module as a main. So if we right click and run the module 6, it will run the same executable code inside the if statement. But so if we try to import the same module, it will not print anything, but the same function is imported, and if we execute it, it will print the message written inside it. Now next topic is controlling wildcard import using init.py file. So earlier we explained with init file you can control which modules gets automatically imported when you are importing a package using wildcard import. So here we have a package A inside the directory which is marked as a content source. Inside package A there is a sub package X, and inside sub package X there are module 1, 2, A and B. 4 modules are inside it, and if we invoke from that sub module import star, which will import all of the modules inside it by default. But we don't want to import all of the module while importing using wildcard. So we can control it using all variable inside the init file. So why we want to control it? So when loading a package using star, your package may contains many number of modules, and if you import them with the star, it can take more load time, and you may not require all the modules inside that package, and you want to by default provide only the set of modules which are important to the user. So in that case you can customize it using all variable, and you can assign a list of string which contains the module names. So here we are only specifying module 1 and module 2 to be imported when using the wildcard import. And after defining all variable, if we try to import using wildcard import, it will only import module 1 and module 2. And if we try to access module A, it is not imported. Next is restricting the wildcard import of functions and variable from a module. So earlier we saw for the package. Same way we can control what gets imported from the module wildcard import. So as we can see here, your module may contain bunch of variables and also functions. And the functions and the variable which begins with underscores or the double underscores are considered as a special variables and functions. So when importing a module using wildcard import, those variables and functions does not get imported by default, but you can access same variable using module import. So this is the import of that particular module, so you can access those special variable and function. But if you are importing module 1 which contains special variables defined with single underscore or the double underscore in the beginning, they are not imported by default using wildcard import. So as we can see here, variable z is imported from the module. Okay, it contains value 30. X is also accessible, but if we try to access y, it will give you name error because it is not imported. But if you want to restrict your wildcard import of normal variable and functions, you can define special variable all, which contains list of string of functions and variable to be imported while using wildcard import. So here we can see it contains variable x, z, a and b and normal function getX. We only want to import variable x, z and function getX when it is imported using wildcard. So we want to omit variable a and b from importing. So if we import this module with variable all, we have variable x and z has same value is defined in module, but if we try to access variable a, it will give you name error because it is not imported. But the same all variable can be imported or accessible if you import module, whole module. So same variable is accessible even though it is not included in the list of all. So if we access it all the special functions and variable which is not included in all are accessible using module import. So they are only restricted while importing a wildcard import. Next topic is relative import. So in Python you can also import module or the package using relative import. So if you see the file structure of it here, the relative import is defined under package A dot package C, and inside it relative import of the directory which is marked as a content source. So this is the path where the Python will look for the import. So inside it can see package A, package C and relative import. So if we want to import the same relative import, we need to write we need to traverse from the package which is right under this folder, which is marked as a content source. So we need to write the whole path. So from package A dot package C import relay or any module other than that. So this module 4, 5 or 6. So if we want to import the same module which is residing in the same package as this relative import, we need to write whole path which is beginning from the content root and reaching to that particular module. So instead of writing all this path, we can use relative import. So with relative import, same module 4 can be imported by referring to the current package using dot, which will mark as a current package of this module. So relative module inside, we are currently inside the relative module, okay, and its current package is C. So from that current package import module 4. So it will import the module 4 which is residing in the same package as the relative import. And if you want to import a module from other package, one hierarchy behind that, so in the same package as the current same package hierarchy and has the same file inside it, so we can write double dot, which will traverse one hierarchy backward. So from going one step backward, we will go to this package. Currently we are at the package C. So if we write double dot, which will go one hierarchy behind, which will select package A, and from package A we are selecting package B. So we are traversing into the package B, and from package B we are importing module 3. So this module is imported using relative import, and it contains say hello function which we are accessing. Same way the module 4 is also containing say hello function which will print the module name. So this way we can perform import of a module which is currently inside the same package of the module which we are coding it or which we are implementing it. And if we want to import from the package in the same hierarchy of the current package of the module is, then we can use double dot, which will traverse one step backward from the current package and selecting the other package which is inside of it, and we can import other module or we can traverse further. So this way we can access the relative import. Now if we execute it, we cannot execute directly from this module. So we will access it from the other module from here, and if we import it, as we can see, it will print the module name, because here we have written the executable code which is executing the say hello function inside module 4 and module 3. So if we again import it, it will not print anything, because in Python modules are only imported once. So this is how relative import works. So until now we have seen regular package and also the namespace package. So we don't need to do anything to mark a package as a namespace package. We just define a package without any init file which will mark that package as a namespace package. Now we will see one advantage which is having with the namespace package is defining a package which is spanning across multiple directories. So here we will see with the example. So we will go inside the namespace folder which is inside the content root, which contains two folders or directories, package 1, package 2, and both of them are marked as a content root, or the both of the directory paths are added to the sys.path. So now both of this directory are in the sys.path, and both contains a directory inside it with the same name, and both of the package are the namespace package because it is not having init file inside it. And here we can see both are containing the folder name are same, but inside that folder it is containing different modules and different packages. So if you have this structure, project structure, and you are using namespace packages, inside the namespace packages, if you have common package, that package by default becomes a namespace package which is spanning across the multiple folders. So even though it is in a different directory, both of the folder will be merged to have a single package, because both of the folder package 1 and package 2 are marked as a content root. So it will find a package or a module from the both of these subdirectory using single namespace. Now what do we mean by it? We will see with the example. So here, as we can see with the import statement, from sub we are importing both of the module, okay, module 1 and module 2. So module 1 and module 2 both have the executable code which will print the function, print the message when it is imported. Okay, so we are importing using single import statement two modules which are defined in the different directories. So this is possible using a namespace packages only. With regular package it is not possible. So if we execute it, as we can see, it is printing message importing module 1 from this folder directory and module 2 from this directory. So although it is having different directory, or we are importing a package which is spanning across the multiple directories, and we are importing modules from the different directory. Same way, using the single namespace sub, we can access both of the packages. So if you want to import both package from sub, we can import both packages sub1 and sub2. Same, so both are in a different directory. One is in package 1 sub1 and other one is a package 2 sub2. But using single namespace sub, we are able to import two packages in a different directories. and you can also import a package or a module inside those packages using this import. So this is the main advantage of namespace package. Now we will see when we are mixing the namespace package with the regular package, what is the order of import. So first, when searching for any package or module, first it will look for the regular package, which means a directory with the given name. So for example, if we are writing only import s1, right, it does not exist right now, but if we are writing import s1, so what happens? So first it will look for a directory in all of the path which are registered with the sys.path. It will look for the directory s1 which contains init.py, which means it is a regular package. If it is not found in all of the directory registered with sys.path, it will look for the s1.py stored at the path which are registered with the sys.path. And then if it don't find there, then it will look for the directory which is a namespace package which does not include init.py. Now we will confirm the same order of import when using mix namespace and regular package with an example. So here we have a pack mix package which contains module s1 and also the same name package s1, which is a regular package because it contains init file and it is having module s1. So for outer s1, if it is imported, it will print importing module s1, and if the regular package is imported, we have importing package s1 inside the init. So if the regular package is imported, we know whatever the content inside the init file is gets executed, and if the package s1 is imported, it will print a module s1 is imported, it will print module s1 from the regular package s1 is imported. But we are not interested in this file. We are interested in what is imported when we write import s1 from package pack mix. So if we visit this order, we know if the module contains the same name as a regular package, package is have more precedence, so it will get imported before the module. So if we import s1, it will import package s1, not module s1, because package s1 is a regular package. So let's execute it, and as we can see, the content inside of init file is executed and your package s1 is imported. Now we will see a second example, which is a pack mix 2. Now it contains a namespace package s1 and a module s1, and we know from this order that module is imported before the namespace package if both have same name. So if we import s1 from pack mix 2, it should import module s1, not import the package s1. So let's execute it and find out. And as we can see, this time module S1 is imported instead of package S1, which is a namespace package. Now you know the order of import if you are mixing the namespace and regular package and module with the same name. Next topic is circular import. So while you are importing it, it might happen that you contain import which is importing other file and that other file is importing the same file. For example, here foo is importing bar module, and from that it is importing bar function, and a bar module which is importing foo modules foo function. So it is a importing each other, and if we execute it, it will give you an error saying that it is most likely due to circular import, because this is importing foo in the beginning and it is importing from bar in the beginning import, so they get intermixed. Because only we are not importing a module, we are importing a particular function from that module, so it is causing a circular import error. Same can be fixed if you are importing module instead of importing any individual function. So for the same code earlier we saw, so for bar and bar fix, it is the same code, but instead of importing a function, we are importing a module, and from that module we are accessing that function. Same way for foo also, we are importing bar module instead of a bar function from the bar module. And if we run it, the same code, it will run just fine. Okay, so always remember to not try to import a particular variable and function from the module. Always try to import whole module, or try to access a particular module from a package, and try to avoid wildcard import as much as possible. Try to import a particular module or a particular module from a package instead of importing all of the content. Next is Zen of Python. So if you write import this and if you execute it, it will print Zen of Python. So it contains how you should write your code, and if you see here in the list of this, it is saying that namespace are one honking great idea. Let's do more of those. It is encouraging you to use namespaces while importing it. So instead of importing variable or a function individually, you import those module or package as a namespaces and try to access it. Now next is importing functionality from the future releases of a Python. So using future, from future, import the name of functionality if you want to import a functionality from the future releases. Now, why you would need it? So if you want to make your code compatible for the future releases you might want to test it using that particular newly added feature. So using this you can import that particular feature. So from Python 2 to Python 3 we know there is a change in a print function. So if we go to the Python 2, here we have changed the Python interpreter to Python 2.7. Python 2 has a print function, print statement like this. It does not contains the brackets. And from Python 3 it has been changed to the print function. Now if you want to access that print function inside the Python 2, we can use future import. And if we try to import it inside the same Python 2, you are able to access same Python function which is by default for the Python version 3 and later. And if you want to check what are the modules you can import using future, you can use dir future, which will give you all the list of modules you can import using future. So ignoring the special variables and constant, these are the modules you can import using future. And if you want to know about it, you can go to the Python documentation and you can know more about these modules. And you can use those functionality which are available in a future releases inside the current release of a Python. So that brings us to the end of the video.